G'day chemistry lovers. So this is going to be chapter 8, which is solutions, concentration and molarity. I'm going to do a selection of pracs for you just so that because you're at home you're going to be able to understand things. First thing that you've been doing already is you know how to calculate number of moles by getting the mass of something and dividing by its molar mass off the periodic table. Sometimes we call it molecular weight instead of molar mass. So you should be very familiar with this formula. Number of moles is mass over molecular weight. We're moving on now to a new concept, which is concentration, sometimes called molarity. So this prac is on page 175. It's prac 8.1. And a key understanding of this prac is that concentration is the number of moles you have per litre of solution. Okay, moles per litre. We use this formula for concentration or molarity. Concentration is number of moles divided by the volume in litres of the substance you have. You can rearrange this formula. You should all be able to rearrange it so you can have number of moles as concentration by volume. Okay, so make sure you understand the simple maths to begin with. For this prac, you're going to be using everyday glassware to make 250 mils of a 0.1 molar sodium chloride solution. It's normal table salt. Should be able to even do this at home. Pretty simple one. Notice the language I'm using here, 0.1 molar. Okay, that's the units used for concentration or molarity. We say the word molar. Okay, and we use the capital M to denote that. Alright, so first thing we're going to do to make this solution is work out the number of moles of sodium chloride that are required for this. Okay, so we use our formula, N equals CV, number of moles equals concentration by volume. Why do we use that? Because we know the concentration they want is 0.1 and we know the volume they want is 250 mils. Big mistake a lot of students make is they do not put that volume in litres there. Okay, so it's 0.1 times 0.25, and then we get the number of moles as 0.025. Okay, so we know an exact amount of moles we need to make up this solution here. Okay. Second step then is, now that we know the amount of moles of sodium chloride we need, we want to convert that into a mass in grams, weigh that out, and then add 250 mils of water to it, and that's it, simply done. So you're going to work out the mass of sodium chloride required. We go back to our time-worn equation here, number of moles is mass over molecular weight. Rearrange it for mass. Mass is number of moles times molecular weight. And we have the number of moles here, 0.025. Timesing it by the molecular weight of sodium, which is 23, and chlorine, which is 35. And we end up with a mass here of 1.46 grams. So that's the maths behind it. I'm going to show you quickly how to do this. Come over to this scale here. You're going to weigh out 1.46 grams here. So what we do is we put our little watch glass on there. So there's our watch glass. We're putting it straight on the scale there. We're going to zero that scale. Okay, then we're going to quickly weigh out this is a sodium chloride here. 1.4 grams of it. Oh, are you serious? First go. Is that 1.4? Richard's confirming it. 1.4. I can't believe that. All right. So we got that there. All we're going to do using everyday glassware again, we're going to tip that straight in there. But look what happens. There's plenty of salt left on there still. So if we're going to be accurate about this, we want to rinse all of that solute into the solvent. Okay, that's important. Going to stir that up, and we're just going to fill that up now to 250 mils. There's 200. Get close to 250, but not right on. This isn't accurate, obviously, because there's a lot of... And then you add drop by drop up to the graduated mark. Okay, so we've got 250 mils now of sodium chloride solution. And we know the exact amount of moles in there. We've weighed out the exact amount of moles. So we know the exact concentration is now 0.1. All right? So now if you can do that, you can come and get a job, a Miss Camilleri or Richard Camilleri, and then you can get yourself a job at university. That's not all it entails, obviously. So that's that. That's the first part of that. Now, if we're going to then, the second part B is a dilution, and it says it wants you to make 250 mils of a 0.01 molar sodium solution from this. Okay? How are we going for time?
5 minutes.
5 minutes, okay, great. So this is a little bit trickier. We've got a known concentration here and a known volume of this solution here. So what we need to do first and foremost is use our formula, number of moles as concentration by volume. We know that our concentration needed is 0.1 molar, and we know our volume, which is 0.25. So we know we need now, to make this solution, we need this many moles, 0.0025 moles, okay? So we have to work out what volume of this solution here that we just made, this 0.1 molar solution, do we need to make that many moles? So what we do is we use our formula again, number of moles is concentration by volume. We put in our knowns. Our knowns is we know how much moles we want. We know the concentration of this solution because we made it already, 0.1. So that then we can solve for volume and work out what volume of this solution we need to make this dilution. And when you work it out, it comes to 25 mils. So using everyday glassware again, quickly doing 25. I won't get this first go, I don't think. And remember, what do we need to measure to? The bottom of the meniscus. And I need to go drop by drop now. So I'm going to use this. You tell me when, Richard.
Bit more.
Yep, bottom of the meniscus there. 25 mils. We're going to use that 25 mils to make this dilution now. We're getting the correct amount of moles in that, and then we're going to add this with some nice pure water up to, again, this is not accurate, is it? But again, up to our 250 mil mark. That's bottom of the meniscus, all good enough for our processes. Signing out, Prac 1. Bye guys.